So, before we start identifying and manipulating network traffic, we first need to understand how computer conversations are initiated in the first place. There are three main players involved. You, as in your personal computer, usually referred to as the host. Your router, which if you are in the UK, may be that box that's provided by Virgin or Sky or BT, or if you're in the US, maybe the box you receive from Verizon or Fios. And the third player is the server, which is essentially another computer like yours, but its main job is to provide you with information. For instance, Google may have large, massive servers that provide you, the host, with information you request. For instance, how do I lose weight quickly and safely? So how does all of this work? First, there needs to be a protocol or a convention that enables the three parties to communicate. This communication, though represented here as being linear, may be quite complex. But for simplicity, let's consider this. You, the host, communicate with your router about the information you would like to receive. Your router then relays that information to the server, for instance Facebook or Google, who then responds with the requested information to your router, who then relays this information back to you. So again, you on your computer request some information. That request is sent to your router. Your router then relays your request to a server that's somewhere on the internet, perhaps in a different country, perhaps in a different city. And once the server receives that request, it then responds with the required information and sends that response back to your router, and your router relays that information back to you, which you then see on your personal computer screen. For all of this to work, each party needs to be able to identify each other. This is where IP addresses come in. In this picture, the IP address of your local computer is 10.0.0.1. The IP address of the router is 150.150.0.1. And the IP address of the server, which would be outside of your home or your local office somewhere across the world, would be 200.100.10.1. Again, this is just an example. These numbers enable each party to identify who is requesting, sending, and receiving information. For example, you type in google.com into your web browser on your local computer, which has this IP address. That request, as discussed before, is sent to your router. Your router looks up this address on its built-in table and identifies that google.com is found at the following IP address, 200.100.10.1. Again, this is just an example. And then sends your requests to these coordinates. Included in this request is we can say a return address, which is the router's own address. So once the request has been filled, the server knows where to respond, where to send back the requested information to. Again, you, the end user, makes a request in your browser. That request is sent to your local router, the box in your home or in your local office. That box has a table that translates addresses like google.com, facebook.com into coordinates or IP addresses, which then gets forwarded to the appropriate server. In this example, the IP address is 200.100.10.1. Included in the request that is sent from your router to the server is a return address, i.e. the address for the router itself, so the server knows where to respond, where to send the requested information to. And once the server sends that information back to your router then can forward that information back to you, the host, on your local computer by using your local IP address. Now, in most cases, your local IP address starts with the number 10 or 192. An important thing to note is that your router rarely sends its requests directly to the server. Instead, what this cloud represents is a network of interconnected computers which carry or relay your request to the server that you request information from. So for instance, if your router received a request from your local computer to visit facebook.com, it may pass through a bunch of other computers before it gets to facebook.com. In turn, the response from facebook.com would then pass through another set of computers before it gets back to your local router. Once the response is received by your router, it's usually a direct connection back to your local computer. This makes sense because if we think about someone who lives in the US and makes a purchase for an item in China using eBay, the seller in China would then send this item to some depot in China. Then maybe it comes by sea or by plane and arrives at a local sorting depot in America before going to the local post office, before getting back to your home. This is what this cloud represents, a network of computers that assists in the relay of information across long distances. We should also note the router is special in that it actually has two IP addresses, though only one is depicted here for simplicity. This IP address is what's known as an external IP address. On this side of the connection, the private network side, the router also has a local IP address, which would look similar to the IP address of the host. So for instance, in this case, the host IP address starts with 10.0. The router would have a similar IP address that starts with 10.0. Or, as mentioned before, in some cases, the IP address of your local computer may be 192 dot something. The router will also have a local IP address which begins with 192. Devices in your home use the router's local IP address to communicate directly with the router. Devices outside of your local network, for instance the server, do not have access to the local IP address of your router. Instead, they communicate with the external IP address of your router. So the way how this works is that all the devices on your network would have a local IP address, let's say 10.0.0.1, 10.0.0.2, 10.0.0.32, or 192, and then end with 2, end with 3, end with 19. So, in a nutshell, all your local devices, i.e. computer, game consoles, etc., communicate with the router using the router's local IP address. Then, all communication outside of the private network, i.e. with the internet, is managed by the external IP address of the router. Once the requested information is received from the servers, it makes its way back to the external IP address of the router. The router then communicates this information to the local devices, i.e. your computer and mobile phones, using the internal IP address system. That is 10 or your 192s. Essentially, the local IP address system is specific to your private and local network. As far as the internet is concerned, your home may only have one IP address. That's the external IP address of the router. However, in order for your router to communicate with different devices in your home network, a local IP system is used.